Today we're taking a look at section 12.4 on measures of position. So far we've talked about measures of center and measures of variation. This is a third type of measure, and it gives us an idea of the relative position of each value as it relates to the other values in the data set. So, the first measure of relative standing that we study, and this is a very important one, it's called the z-score. The z-score tells how many standard deviations above or below the mean the given value lies. A positive z-score is above the mean, a negative z-score is below the mean, and a zero z-score is at the mean. And the way we calculate it for a sample, and you're going to need to add this. Let me see if I can get my pen to work here. Okay. It's x minus, it's the data value minus the mean divided by the standard deviation. And you should round that to the nearest hundredth when you're calculating. So a z-score should be rounded to 2 decimal places. So to find the z-score for a data value, we take the data value minus the mean of the sample and then divide it by the standard deviation of the sample. That's going to tell us how many standard deviations above or below the mean our value is located. Now, a positive z-score, as I mentioned, means it's above the mean or greater than the mean. A negative z-score would indicate it's below the mean or to the left of the mean. So the z-score is very important, and particularly when we take a look at the normal distribution in a later section. And in the normal distribution we use a table, and the table is given to the nearest hundredth. So that's the reason we round it to the nearest hundredth. Okay, so we also can talk about, in addition to z-score, we have some other measures of position, and these are called percentiles, deciles, and quartiles. When working with a set of numbers, we can divide the list of numbers into 100 pieces using 99 percentiles. This is commonly done with standardized tests. And what happens is you get a percentile score, and what that does is that compares you to the rest of the people at the same level taking the same test. So if you score, say, in the 85th percentile in math, that would indicate that you scored better than 85% of the people taking the test at the same level. It would also mean that 15% scored above you, 15% of the people. So that's what the percentiles mean. It doesn't mean that you got 99 out of 100 right in terms of the score. It has to do with how you compare, how your score compares with other people at the same level. We can also use deciles. There are 9 deciles that divide data into 10 pieces. And we also use what are called quartiles, and data is divided into 4 pieces using 3 quartiles. The most common of these, of course, is the percentile, and also then followed by the quartile, and I would say decile is probably the least used. Notice that the median, which is our middle value, is the same as the 50th percentile, the 5th decile, or the 2nd quartile. All of those would mean the same thing. The 25th percentile separates the bottom 25% of the values from the upper 75% of the values. So the 25th percentile would be the same thing as the first quartile. Now my question is, so what would be the quartile representing the 75th percentile? So the 17th percentile would mean that we would have 75% of the scores below that, or 3/4, so it represents the 3rd quartile. Now, these are the 2 things that we have to do in working with data values. We have to be able to find the percentile ranking of a value, and we have to be able to find the value that is at a given percentile. So the first of these, what we do to find the percentile ranking of a data value is we count the number of values less than our data value x and divide by the total number of values. That's going to give us a decimal. We multiply by 100 and round to the nearest whole number. And we're going to do some examples of these shortly. All right, to find the value that is at a given percentile, we want to divide the percentile number, which we call k, by 100 and multiply the number of values multiply that by the number of values in the list. If the result is not a whole number, we round it up to the next largest whole number, and we count to that value in the list. So this is actually what we call a locator formula. So you can see k divided by 100 times n. And if the result is a whole number, your answer will be halfway between that value and the next value. Okay, I'm sure that all of this sounds like foreign language right now. So let's start with our list of numbers, and I've already put these in order. These are some quiz scores or test scores. I'm not sure which one or the other. And so how would we go about finding these? And let me go here and get my calculator up, since I didn't grab my calculator before I sat down to record this. Okay, that should be coming up briefly. There we go. Okay, so we've got the calculator. Let's look at our first question, and we can use that then. We have a list of numbers, and let's see how many numbers we have. And I'm going to number these on the side, and you'll see why this will be useful in a moment. Okay, we have 24 values. So to find P72, we want to take 72 divided by 100, which is 0.72, and I'm going to multiply it times the number of values. Okay, so 0.72 times 24. Get my calculator here. I'm going to clear this off. 0.72 times 24. Okay, so I'm getting 17.28. So I'm going to round that up to 18. I want to take the 18th number. Okay, so number 18, 16, 17, 18 is a 96. Okay, the 32nd percent or 36th percentile, I'm going to do much the same way. All right, so 0.36. By 24 is 8.64. So I'm going to take the 9th value. Okay, so there it is, 88. Okay, the first quartile is 1/4, which is 0.25, 25 hundredths. Now on this one I'm going to get a whole number. 1/4 of 24 is going to give me a 6. So it's going to be between the 6th and the 7th. So let's go over here. 6 is an 80, 7 is an 80, so it will be 80. Okay, the third quartile. Again, when we take 3/4 of 24, we're going to get, was it 18? So it's going to be between the 18th and the 19th. Let me make sure my arithmetic in my head is correct. Yeah, 18 is correct. Okay, so we have between the 18th and the 19th, both of them are 96s, so that would be a 96. Okay, the fourth decile, that would be 4 over 10, or 0.4. Alright, I would go back to my calculator. 0.4 times 24, and that's 9.6, so we're going to take the 10th one. So this is 9.6, so we're going to take the 10th value. The 10th value is right here, so that would be an 88. The 9th decile would be 90 out of 100, or 0.9. Okay, so 0.9. Go back to my calculator. 0.9 times 24 is 21.6. So we want to take the 22nd value in the list, and I can see 22nd value, see 21, 22, 23. Here's the 22nd one, is 100. Okay, now what is the percentile ranking of 76? Let me get my pens on a highlighter. So here's 76. I want to count the number of values less than 76. How many values are less than 76? And I see 1, 2, 3, 4. 4 out of 24. So that's going to be 1/6. So 1 divided by 6. And we multiply it by 100 to get it as a percentage. It's going to be 16.7, so we're going to count that as a whole number. It would be the 17th percentile. So P17 is 76. Alright, let me erase that one. Alright, and let's highlight the next one. Percentile ranking of 84. Here's our 84. We want to count the number of values less than 84. We see it's 7. So again, we need to change this to a percent. So 7 divided by 24, and then times 100. So we're getting 29.2, which would be rounded to 29%. So that's the 29th percentile. Okay. And we have 2 more, so let's see. Let me erase the last one. Oops. I'm going to keep all my numbers in here. What is the percentile ranking of 80? We want to take the 80 that is closest to the lower numbers. So we count 1, 2, 3, 4, 5. So that's 5 over 24. So again, we need to calculate. So I'm going to do 5 divided by 24, and then times 100 to move the decimal point. So 20.8 would be 21%, 21st percentile.